Hello everyone, and in today's video I am back with another video. So I've not been uploading for a few weeks and for a few days, sorry, because I was unwell, but now I'm back again. And actually, because I have not been here for a few days, I actually have surprised you with a full-on deep dive of thunderstorms. Yesterday I posted a community post about what I was going to it was going to be a very good video. So here is very good slide presentation, 51 slides. Hope you enjoy this video, and let's get straight into it. But again, sorry for that, another apology for you guys. Sorry again, I was sick, really unwell, really tired, could not be bothered to upload, but here I am back again, and here's me doing this last slide just to own up that apology. Hope that really helps. Yesterday I was literally up at night time doing this. Yesterday I was in the morning, I was doing this for 1-2 hours. So please, I do hope you enjoy this. Thank you very much. Let's get started. Again, we're going to thunderstorms. This will be a long video. Please expect keywords to be thrown around repeatedly, especially weather keywords. There will be a keyword bank in the description, and also parts of the video you find sometimes parts of the video is boring, which some of you may, feel free to skip to any timestamp linked into the description. Again, if you don't understand anything, frequently asked question again will be in the description. But I will try to say and understand this make this as easy as possible to understand. Again, make it a long time to make, around 3 hours. So please enjoy. Part 1, type of thunderstorms. So the keywords: updraft, it means warm moist air to create clouds. What that basically means: warm air from the ground rising up. Downdraft, the opposite: cold air descending from the cloud towards the ground. Cumulus, you could have watched my cloud tutorial series, and some of you may already know this, but again, there's a cloud type formed by convection. Typically these clouds won't really be that destructive. Really, typical day cumulus clouds, really nice days, that's what you see with them. Cumulonimbus clouds, sometimes you may see them elsewhere. Again, it's a type of cloud will form by this cumulus right here, and it's going to be built up by a cumulonimbus, which is a thunderstorm by convection. Cumulonimbus clouds, they are basically cumulus clouds, but a lot bigger, a lot taller, and it has got like a weird anvil shaped with kind of icy on the tops of it. I'll go into that later into a deep dive. You might not understand me now, but don't worry, these keywords will be used and I'll be explaining how it works later on. Convection, the up and down movement to fuel thunderstorms. So again, instability, you can call this again to basically make thunderstorms. A lot of convection typically means more thunderstorms. Now here, wind shear, the change of wind direction and or speed in different altitudes. So wind shear, you tend to get it with you tend to get with a lot of wind shear in summer, especially in summer, because you don't know what to expect in summer. Basically, those winds could change in altitude, could change in direction. That's what basically wind shear is. Mesocyclone, this one's the only one that is in the. This is the only one which I'll use in a supercell. Mesocyclone never appear inside any storm other than a supercell thunderstorm. Large column of rotating air within a thunderstorm. Mesocyclone, remember that word, really important when we talk about supercells. Very complicated, but again, don't have to understand it fully, just really the basics of it will already be nice. Shelf cloud, basically just literally what the word means. A shelf cloud means the cloud looks like a shelf. A wedge-shaped cloud attached to its parent storm, thunderstorm actually. So 4 types of thunderstorm: single cell, multi-cell, score line, and supercells. We'll have a look at all 4 in today's video. So starting off with single cell. Main info, usually described as a post storm. These are very light storms, they do not last long. One updraft, remember what updraft is? Rising column of rising air from the surface. And that leads to cloud formation. Low impact, don't worry about these. These tend to appear a lot in the UK, especially in spring or summer. They're the most common in. Usually these will last from 30 minutes, maximum 2 hours. No wind shear, and is typically caused by summer heat, or spring heat, heating up the ground, rising air, rising updraft, forming cloud. Supercell, you get that towering cumulus cloud. Single cell building up, precipitation force. Downdraft brings along the updraft. Downdraft goes stronger than the updraft. Then apparently, after the downdraft is stronger than the updraft, the storm can't rebuild again. That's why it's so low impact. These single cell storms, really, all you get, that information is very simple here, right here. And these scales, I've actually made this look quite nice. The wind speed wouldn't be that much, but could have that isolated gust of wind where it's quite strong. You can expect hail with these storms, and also flooding issues, and quite likely again 30 minutes to 2 hours, maybe very, very localized. But again, that flooding, I put that near that green area there. Tornado, very, very, I would say 0.001%. These storms, almost never, these storms ever make up a tornado. That's why you see a very, very tiny gap there. That's why I left there. Just very, very less. Almost impossible with these single cell storms to even create a tornado at any point circumstances. But lightning, it does go near orange, and the reason for that is because it has got a lot of activity in there, a lot of instability, a lot of convection. Remember what convection was? Up and down movement to fuel thunderstorms. Lot of instability that causes a lot of lightning, but overall low impact. That's what it is. Doesn't cause much issues along with it anyway. Described as post storm, 30 minutes to 2 hours, and no wind shear. These are example images by. Credits are down here always. Every single picture I have a credit down here. Every time I do these presentations, always will have a credit down here. Keep in mind, these are only picture credits, not this whole PowerPoint is made by me. It's only these pictures that are credited to these websites here. Example images. This is a single cell. You see, very, very large, but you see, the reason why I put a tornado like this, look at this. Look at that. How is that going to form a tornado? No way. But some of you might say, why is this thing not a tornado? This thing is at the precipitation. This is not a tornado. It's a precipitation. So everyone gets confused about this. This is not a tornado. I repeat, it's the rain band coming down with that cloud. This is the downdraft area here with that rain carrying down there. So it's not a tornado. But again, this single cell you see is quite iced up here. This is what you would call a fully formed single cell, or if you want to keep it simple, call it a cumulonimbus cloud. Thunderstorm, ordinary or single cell, multi-cell storm, single cell storm. This is a single cell storm. Typical cumulonimbus, single cell thunderstorm, produces very heavy showers, possibly hail and lightning. Again, these storms, this one, very icy top, very fuzzy, very icy, not much texture. Again, you see that rain coming down in there, not a tornado, just rain coming down in there. So high precipitation along with these, but not as much as what we're about to see later on in the video. The life cycle here, towering cumulus stage, that's the first stage. Again, remember updraft, arrows are going up. This is an updraft. So it's driving air from the ground, moving up the atmosphere. What's that going to do? It's going to form a cloud, isn't it? That cloud, as that updraft will continue to push that cloud up, that cloud will continue to move up with the updraft. That's what stretches this cloud. I'm talking about stretching. Let's move on to the mature stage. Now, mature stage, the updraft has gone up here near the troposphere, 40,000 feet. And up here, we get a fully developed single cell. Here, because the cloud is so heavy, raindrops, we start to get precipitation falling down. And precipitation isn't going up. Precipitation / rain is going downward. And downward, we have a key term for that. It was a downdraft. So whenever you get precipitation, always a downdraft. So arrows are going down here. You see these updrafts turning this way. Arrow just goes down here. And when the arrow go down here, you can see this shade here, storm, accompanied with this here. And then the dissipating stage will be the updraft. You see, remember, I did say the dissipating stage was the downdraft. It was the downdraft pulling on the updraft. So you can see first cumulus was only updraft, mature stage updraft and downdraft, and dissipating stage only downdraft. And the reason for that is that downdraft too strong for that updraft to continue. Therefore, we're only left with this top icy part here, which is what this image was showing us right there. But even in the dissipating stage, you see still that downdraft is there, and when we get downdraft, it means rain. So again, life cycle of a cumulonimbus cloud single cell. That's how easy I can explain it. The formation, again, formed in warm and sunny summer afternoons, typically formed by sun heating up the ground again, starting with cumulus cloud, developing into a storm cloud, which is this word cumulonimbus. Going back to this one here, cumulonimbus. This one's a cumulonimbus. This one's a cumulus. This one's a cumulonimbus. You see that difference right there? Much bigger with this cumulonimbus and much smaller with this cumulus. The impact. Low impact, they don't cause much harm, although they will occasionally drop hail, and sometimes it does cause some issues again with thunderstorms and lightning as well. Near impossible chance for tornadoes. Very unlikely unless it does get very big. Moderate to frequent lightning activity. You do get a few strikes with these storms. Not as much as what we're about to see next, but still, you do still get a few flashes. High precipitation and last from 30 minutes to an hour. So this was single cells covered. Multi-cell next. Usually organized in a line. These are line storms. Even some people can call them multi-cell line if they wanted. Multi-cell line if they wanted to, or multi-cell cluster if they wanted to. These are multiple cells, and cells, I don't mean that kind of cell. I mean cells as in multi-cell, single cell, that kind of cell. So multiple cells, I don't mean multiple multi-cell because you don't even know what they are. Multiple single cells is in a multi-cell. Medium impact, lasts a few hours to a day. These storms are much more organized than a single cell, so they last much longer, and they form with low to mid wind shear. Wind will be very similar to a single cell. Hail, much higher, up to the orange bits, near red. So hail, you tend to get a lot dropping under one place. Flooding, up to red. The reason for that, I'll explain it later, but the reason for that, you get dumped with a lot of rain with multi-cell, especially on one place, on a city or something like that. You tend to get dumped with a lot of rain, awfully lot with these storms. Tornado, there is actually a chance because it's big enough, but just keep in mind, tornadoes always have to be formed from mesocyclone, obviously. But lightning is actually a little bit more frequent than a single cell, because multi-cells have got multiple single cells going on, while a single cell only have one cell going on. But the overall is actually at around near that boundary between orange and red, and the reason I put it there is really medium. These again have a lot of hazard with them. Multiple cell, I mean this. See these one here, 1, 2, 3, divide by lines. Cell 1 here, 1. All of these numbers are all single cells, and these cells here, all of these are single cells. So you got one cell here, one cell here, one cell here, one cell here, and as the storm motion is pointing this way, and because we get this structure, we get a lot of rain, awfully a lot of rain dumping here. This picture doesn't really show it, but as we move on to the next one, here, life cycle of a multicell. Much more complicated. You might not understand, but do feel free to ask me in the comments if you don't. Life cycle of a multicell. So there's a cell 1 here, but there is a cell 2. Cell 2, let's take cell 2. Cell 2 has followed the life cycle of a single cell storm, which was this, wasn't it? It was this: towering, mature, and dissipate. So cell 2 have followed that and it's dissipating now. Cell 3 is at its mature stage. Cell 4 is at the this stage right here, towering cumulus, and 5 and 6 are as well. But what we get from this is we get a pattern. After cell 2 is died out, after cell 2 is not here anymore, just clean air, cell 3 moves to the cell 2 position and it starts dissipating. Cell 4 matures, cell 5 becomes cell 4, cell 6 becomes cell 5, and then there's a newly born cell called cell 7, which will take cell 6's position. And this is why I say I put precipitation, I put flooding here. And because again, it dumps a lot of rain, very organized, and because it keeps forming like this, the reason why it keeps falling is because when we get downdraft, we get wind shear, and when that wind shear is going to push this thing called a gust front. That gust front is then going to travel on the ground, create straight line winds, and then after that it's going to divert back up the ground and it's going to create another updraft. So that's how it's working with this gust front. Without this gust front, it would just be a single cell, but with single cells, remember, no wind shear. With multi-cells, we need this gust front, and the only way for this gust front to form is with the wind shear. Formation. Form an adjacent single cell from a gust front made of multiple single cells, like I said. These cells are medium impact. These storms may, and I highlight that may, cause several impacts. Occasional chance for tornadoes, frequent lightning activity, high precipitation, and again can last up to days or even a week with these storms as well. School line. Looks like an eerie shelf cloud, showing you a picture later. Very hard to picture, I know. A line, medium to high impact, vast distances, low to medium wind shear, very high precipitation, and sometimes when you're inside that shelf cloud, it can describe as a whale's mouth. And the scales are actually medium to high. The winds are up to here. The winds are even stronger in the score line than any other cell in here listed. That's the third type of thunderstorm. Hail, you do tend to get some of this. Not always, but sometimes. Flooding, not really. Not as bad as a multi-cell, but still you do get over a period of very heavy rain. Tornado, you are actually quite likely to get tornadoes with this, especially if it's a score line in the USA. Score line in the UK, maybe up to that green or yellowish region, because doesn't have enough that convection. But tornado is score line tornado inside USA is quite likely. But talking about UK, it's going to be somewhere around down here. But overall, this is still a worldwide presentation. Don't have to watch this if you're in the UK. You can watch this anywhere around the world. Lightning can be up to here as well, but overall with these scales I put as medium to high risk. This is what it looks like. I know, very no, this looks like it's fake, but it's actually not fake. This is literally what happens in a shelf cloud. Again, if you're swallowed inside one, it looks like a whale's mouth. Literally, you do not want to see that. Very dark inside of it. You do not want to be trapped inside of it. But what you do see, if one is approaching you, is something like this from the radar, if you have got one, is you see this red bit in here. The red in here really shows that as soon as As soon as this shelf has crossed you, you prepare yourself for very, 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 and I mean very heavy rain, destructive, for 10 to 15 minutes of very, very strong rain. And I mean very, very strong rain, with accompanied with very strong winds. Even though it's a calm day, when you get this crossing over you, you get very, very strong, even straight line winds possible with these storms. But after that 15-minute maximum, it does calm down a little bit, going back to that yellow-green region where it does slowly die out until you're back into no rain again, back into sunshine. So that is typically how a shelf cloud is like. The formation is formed with slight and to medium wind shear, is formed in a line shape. It can stretch for thousands of miles, like this one right here. Look at this. One from all the way on top of the map towards the bottom. Look at this, really, really stretched out, could stretch even hundreds to thousands of miles. You never know. The line looks like a shelf again, very obvious. Impact, these storms are medium to high impact. These storms may cause numerous impacts, may have a chance for tornadoes, frequent lightning activity, and very high precipitation from the first 5 to 10 minutes, damaging straight line winds. Supercell, the mother of storms. This is usually described as the mother of storms. And main features, this is the main one, a rotating updraft. Contains a mesocyclone. A mesocyclone, remember, it was a rotating column of air, a rotating updraft basically. Contains a rotating updraft. So, typically high impact, lasts up to days. High wind shear, high precipitation, strong or deadly tornadoes possible, strongest storms on Earth. So really, these storms are really, really high. All of these nearly are on red or even pink here. Wind and hail, very similar. Within that boundary there, it's got, these hail really can cause a lot. These supercell hails, I'm not even joking, can even as big as tennis. You never know how big these can get up in the air. Flooding, I would say around that orange to red bit, not as much as a multi-cell anyway. Multi-cell is the flooding champion here. But tornado, look at this. I put it as nearly a peg. And tornado is what makes this scale high to dangerous. Tornado is strong. You're talking about year 4, year 5 on the scale here with these supercells. So very, very deadly tornadoes, definitely. The most deadly tornadoes come from this name here, supercell up here. But we'll get onto that later. Lightning. Very similar to all storms. Overall, very, very high. Example image. This is a mesocyclone, a rotating. You see, this looks like something out of a sci-fi movie. It's not fake again. All of these, everything I show you in this video will be real. This whole thing is a rotating column of updraft. Is rotating up. This a thunderstorm. Life cycle of a supercell, again, rotating updraft, mesocyclone. So again, very complicated here. We got a forward flank downdraft. Even myself, I don't know every single aspect of this, but I do know some of it. Here's the inflow, here's the outflow. But notice the inflow has got nothing, got no precipitation, while the outflow, this is where the storm takes in the energy, and this is where the storm takes out the energy in the outflow with rain and hail. There's a wall cloud that forms within the inflow, and that's the worst place you want to be when you storm chase a supercell. Any tornado, any time can spawn in there. Tail cloud, that's what you get from the edge of it. Rain and hail, you really can't see anything when you're driving in the outflow. Forward flank downdraft, this is the downdraft causing the outflow. Flanking line, this is the line of cumulus cloud. Rear flank downdraft, can't really explain this because I don't have a deep understanding on this. But overshooting top, overshooting top is really common within these thunderstorms. So supercell, or if you don't understand this, very simple. Rotating updraft, that's all you need to know to spot a supercell. Formation. Form with slight to high, no, not meant to be slight, but meant to be high wind shear. Rotating and tilting updraft. You see this is tilting a little bit here. This whole structure storm is tilting a lot here actually with the wind shear. Contains a rotating mesocyclone formed by high cape and instability. I'll talk more about cape later in the video. Impact these storms are high impact. These storms may cause severe impact, likely for a chance for tornadoes. A small chance for severe prolonged wide tornadoes and can last up to a few days. Not tornadoes, but a storm. Part 2. What do you need for a thunderstorm? 3 main ingredients here in the list. Moisture, unstable air, lift. If you don't know where I am, I'm about to explain them. Moisture. So, moisture in the air is typically come from the ocean, and areas near warm ocean often evaporates lots of moisture into the air. That's how moisture is coming from. Moisture in the air is also responsible for making clouds. You see development here in the diagram, showing really nice here with these clouds here developed by the moisture. Unstable air and the lift. Unstable air forms when warm moist air near the ground is met with cold dry air is up above. To create a thunderstorm, the unstable air needs to have a nudge upwards. That brings me on to lift. The lift is usually come from differences in air density. Warmer, less dense air rise upwards, creating lift. As the air rises higher, it causes a storm cloud to go higher, higher, and taller. Thunderstorm cloud can now reach up to 10 miles higher, 10 miles into the air, or 60,000 feet. In a big thunderstorm cloud, upward winds and downward winds, called updraft and downdraft, we talked about this, happens at the same time. And this is the most dangerous part of the storm when tornadoes win. And this is a fully developed storm now with this diagram. And when tornadoes, hail winds can occur, updraft fill the storm with warm, moist air. The storm weakens when it runs off updraft, and rain and wind become less intense. By the end, it's just left with is a blue sky and an anvil-shaped cloud top. Like, let's go back to far back towards up to this one left with this cloud right here. So let's going back to here. What is CAPE? So CAPE stands for convective available potential energy. What do you need for a storm? This CAPE thing is a very big thing for storms as well. So already you see, CAPE stands for convective available potential energy. It's a measure of how much energy is available in the atmosphere to trigger thunderstorms. High CAPE levels mean more likely of severe weather. CAPE tends to peak in summer in the UK, whilst in the USA this can be all year round. This is a picture displaying CAPE trough of USA. There's no credit because I took this picture. And here you can see USA again. These shades are basically CAPE levels with red and purple, or lighter shades, or even white and grey in them. It means that it's going to be very high CAPE. Part 3, lightning and thunder. How does lightning form? Lightning is basically a huge spark, either inside a cloud or between the cloud and ground. It forms because the ice particles inside a cloud bump into each other millions of times, and it builds up electric charge. As these charges spread apart, large regions of the charge develop. Once the charge is strong enough, a lightning strikes happens. When lightning strikes head towards the ground, it starts with a step leader, a channel that moves downwards in small steps. The first one that hits that positive is gonna, when it finally connects with the ground is a positive, a full channel forms, and a return stroke occurs, which is the bright flash lightning strike we see. So, how lightning develops: positive charges, negative charges from the lightning, and positive charges at the top. Lightning travels down here towards the ground with positive charges, negative current and positive current. The ground meets the negative, the positive wants to meet the negative, and the negative wants to meet the positive, and they both connect to each other. And the moment they connect, this is a lightning flash. Thunder happens because lightning's intense heating of air causes it to expand rapidly and quickly, creating a shock wave 30,000 degrees within a few seconds, within less than 1 second in a lightning strike. There can be different sounds of thunder. Nearby lightning strikes will sound like a loud bang, crack, or snap, but of very short duration. As a shortwave travels further away from the strike, the sound wave stretches, diminishes, and becomes longer. Therefore, further away lightning strikes will sound more of a deep rumble than a sudden slap. Thunder is usually heard up to 10 miles away from the strike, 16 kilometers, but quieter conditions can be up to 25 miles or even up to 40 kilometers. Light versus sound. A lot of you know this, but I just do want to include this in the PowerPoint. If some of you don't know, thunder is heard after lightning because light travels much faster than sound. Thunder, light from the lightning strike travels at 186,282 miles per second. So, which is 299,792 kilometers per second. Sound only travels 1,120 feet, which is 333 meters per second. A lot slower. How far away is a storm? There's actually a technique to do this. And if you count the seconds, when you see a lightning flash, immediately start counting the seconds until you hear the rumble of thunder. And if it's a decimal, round it towards the nearest integer. Divide the number of seconds by 5 to get approximate distance in miles, or divide it by 3 for an approximate distance in kilometers. You can try that when it's a thunderstorm. Common lightning myths. If it's not raining, you're safe. Nope, that's not true. Lightning strikes can be up to 10 meters away from a thunderstorm. Even though it's not raining, it does not mean you're safe. Lightning does not strike the same place twice. This be a really popular and controversial one. False. Places like the Empire State Building get struck by lightning hundreds of times each year. Hiding in a tree is safe? Absolutely not. Trees actually attract lightning. It can be like a shelter, but it's actually not. It attracts lightning. Being near one actually increases your risk instead of saving you. Types of lightning. Very complicated. We'll start near the troposphere. Of course, we got the cloud to ground lightning, short form for CG lightning, cloud to cloud lightning, which is the typical one you get with cumulonimbus clouds. Ground to cloud lightning, which is ground lightning going up to the cloud. Very rare, but you do see it within most likely a score line. And up here, let's go up now towards tendrils. You only see these up here if you get a clear sky. If you don't get a clear sky, no, you can't see any of these. But tendrils, every single one of these is quite rare. Tendrils, I don't really know what they are, but I do know what sprites are. Sprites are basically every time a lightning strikes 50 miles above that cumulonimbus cloud, that thunder cloud, every time a lightning strikes, that's very dim sprites will appear on the top, and this thing called eaves, I don't know what that is either. You can research them yourself, but basically I think it is a ring around the sprite, which again could trigger every time a thunderstorm occurs. Again, I'm not really into these things, into these types of lightning that much. I'm not really that much of a professional in that, but you can research if you want. 4. Severe weather and risks. Almost at the end. Severe thunderstorm risk categories. Marginal. Isolated thunderstorms possible. Slight. Scattered severe thunderstorms possible. Enhanced. Numerous severe thunderstorms possible. Moderate, widespread, intense severe thunderstorms likely. High, widespread, intense thunderstorms expected. This is mostly used in USA, but although some other countries do still use it, so for the sake of this video, I will still cover this. Hail. Hail starts with small, tiny pellets inside storm clouds. Updraft in the cloud push them upwards multiple times, adding on a layer of ice every time it does so, until they get too heavy and fall to the ground. Stronger storms contain bigger hail, can be as big as a tennis ball. Large hail can break cars, windshields, and destroy crops. Extreme hailstorms, which is very unlikely, can cause fatal injuries. One of the largest one recorded was one as big as a grapefruit. The heaviest one recorded was one weighing nearly 1 kg. Tornadoes. So this is, I'm not sure if this is international or not, but this is from the International Code Council. So I did just pick this one up just in case it was international. But this is the tornado. So 0 is basically very, very, very rare, but it does happen in some spots. Peeled surface of some roofs, some damages to gutters or sliding. This is really the weakest one you ever see. 1. Roofs severely stripped, mobile homes overturned or badly damaged, loss of interior doors, windows or other glass broken. EF1, this is still weak compared to the stronger ones. 2. EF2, roofs torn off some well-structured homes, foundation of frame homes shifted, mobile homes completely destroyed. 3. Empire stories of well-structured homes could be destroyed, severe damage to large buildings such as shopping malls. 4. We're starting to get severe now. Well-constructed homes and whole frame homes completely demolished. And 5. Strong frame houses leveled off foundations and swept away. High-rise buildings will have a significant structural deformation. So 5 is the strongest one here with up to 200 miles per hour. 4 and 5 is very rare. I would say the most common one is around 1 to 2, so don't worry about it too much. But we don't get tornadoes that much here in the UK anyway. That really happens in hotspots like the USA. The final one, top 5 websites I recommend. Lightning Tracker, lightningmaps.org. This website detects every single lightning strike in the whole world in real time. Wixcharts.com. This chart is very easy to navigate with different types of charts with models. You can basically see everything in this chart. Very useful. I use it in my weather forecasting videos. UK weather. Very useful for tracking UK weather, especially the UKV chart. It has all the features you need from precipitation, temperatures, snowfall to cloud amounts. Weather warnings. So this is the official Met Office tracking weather warnings in your area. Don't ignore this. This was previous. This is not now. So ignore this warning here. This is just an image I've taken from Met Office. And live radar. You can track any storms, precipitations, or clouds in real life using this website. Live radar is basically weather.com, and then click on the radar button, and then you can probably see the radar on there if you really want to track a storm. So basically done. Thank you for watching this video. I went very deep dive in this video. Description, I'll probably do it somewhere around tomorrow because or maybe today if I have enough time to do it today. But at this point, if you don't see a description, it will definitely be there tomorrow. I do need to get this out as quickly as I can. Thank you for watching this video, and I really hope you enjoyed. It took a long time to make, a lot of effort, and thank you very much for this video. Thanks for watching. If you're making it here, thank you very much. I hope you enjoyed it, and until the next time, goodbye.